In this video, we would like to explain about performing the linear regression analysis using Python. Regression is nothing but a relationship between two or more variables. One is called as independent variable and other is called as dependent variables. So that data we may have and this data may have a size n, and that is nothing but the observations. So I is an observation 1 2 3 up to n. So there are n number of observations for the relationship of x and y which we want to see. So in this case, regression is nothing but developing a relationship between x and y. Y is considered as a function of x. If it is a linear function, we can consider equation as y is equal to a plus bx. So now in this case, b is a slope, a is a constant, and if the data is plotted over the curve scatter diagram, so the relationship may be some kind of relation this way. As the data has more things, so the ideal relationship which is considered is mu of y with respect to x is nothing but what we called beta naught plus beta 1 x plus, this is linear regression model, beta naught plus beta 1 x plus error. So now the estimate of it, estimated model, which is a relationship, is nothing but y estimated is equal to a plus bx, or sometimes it is called as b naught plus b1 x, whatever way we want to represent it. Now we take an example performing regression analysis for two types of two types of variables. One is dynamic lift and the other is arm strength. So for individuals arm strength, what the dynamic lift we are going to get, the data we can obtain from the link given here. If we see these data, it is in the form of the columns which we can download: individual number, strength and lift. So we can see these three columns here where the data can be downloaded. Once the data is downloaded, we can open it Excel file. So there are three columns of data. We can save it at a particular location where we want to save the programs. So we can go there. Py program is a folder we are considering as a path over here. So data can be saved as a data file. So once the file is saved, now we want to write a program, but before that, there are two options to do this. One is using Numpy, where you perform mathematical calculations over the data, and the other is using Statsmodels of the Python modules. So these are two modules, one of them we can use. As we see, the data is in the form of three columns here: I, X, Y. So the last one is nothing but n, which is the size of the data. You can have summation of x, you can have summation of y, but as per statistics and models, these estimates a or b or b naught or b1 are nothing but the formula we have: summation y summation x square minus summation x summation xy divided by n summation x square minus summation x whole square. And the b1, which is nothing but a slope, is n summation xy minus summation x summation y divided by the same term, denominator, sigma x square minus sigma x whole square. So if we have to calculate these terms, we should know the values of what is called as summation y summation x square summation x summation xy. So these terms we do require to find out the values of b naught and b1, which can be obtained by adding a column here, x square. We can add a column x square, we can add a column xy. So here you can get summation x square and here you can get summation xy. Rest of them are with you. So if you get the sum of these, you can solve it for b naught and b1. So how do we solve it for using the Python? We can go to the Python file editor. So in this, first of all, we can open a folder Folder is a location where we want to keep our data as well as programs. So if we open this, the data is already there. We had already saved this CSV file, comma separated file is there. Now if we want to write a program, we can open a new file and we have to save it as, for example, linear regression 1.py extension is required here. So if we are solving using Numpy, then we have to import it first. Import Numpy as np, let's have. And because data frame we want to use, so we have to import pandas as p. Now first of all we have to read the data, so we can give a variable data frame equal to pd dot read underscore csv. So CSV is what we require. We can also use read underscore excel for excel file. This is data.csv. We have this. We can print, use print command for df.head. So we can just see the header of it. So to run this, we will go to command prompt. In command prompt, we will go to directory cd py underscore prod. So we are here, we will write py just to see a larger view of it. Py len underscore reg1.py. We run it and we see that the data frame is created with the index 0 to 25, individual number is 1, strength is this. So if we want to change the header of it, we can have another data frame df1 equal to df.head, df.columns. So if we want to change the header of the data frame, we will write simply df columns equals, within the list we can give the values I comma x comma y. So if we change this, index is important, print again data frame dot head. So we will see how it goes. We will run the program and we will see it, the header is changed now. So now we can see the header as xi xy. So these are the things we need not to print again. So we can comment it, and now our columns are, we can have x variable as df x, we can have y variable as df y. So for simplicity we have this thing. Now the all calculation for b0 and b1, we can create a function. So df, we can create a function regression colon and for this we can have linear regression. So we can have it here. So first of all you have to find out the value of n. N is nothing but length of either df or length of x, both will work the same way. Then we can find out the denominator, because denominator is common to all. It is nothing but n multiplied by np is used for numpy, not sum of the values. What we have, x square, so it will be x multiplied by x simply, minus summation of x square, so it will be np dot sum of x multiplied by np dot sum of x. So this is a denominator we get. Then we can have b0 or a, whatever you call it. So that will be our summation y multiplied by summation x square. So np dot sum y multiplied by np dot sum x square minus np dot sum of x multiplied by np dot sum of y. So that whole will be divided by denominator. Then we can have b1 as equal to np dot, this is n multiplied by np dot sum of the product x into y minus np dot sum of x multiplied by np dot sum of y divided by denominator. So we get these two values which have to be returned. So we will return them b0 comma b1. So wherever you will call the function, it will return the values. So as we have x and y as a global variable over there, we can send these values to a function. We can call a variable, for example b0 comma b1 equal to linear regression. We can call it as x comma y, but we had to send the variables over here. So here we may write as x comma y. So x comma y will go there. So we may write it as anything, any name we can have. This we can give any name. So both ways as possible. We can write b0 comma b1 equals, we can also name it as a and b if we like. This equal to linear underscore regression. We can have df x comma df y. Both ways we should get the same printout. Print bin, we may write it as y estimated equals comma b0 comma, we can create a concatenate string command, and then we can have create a space over there. We can have this, sorry, b1 comma multiplied by x. So this is the equation we can get from method 1, and the same thing we can print again having a and b. So we suppose that the answer must be same for both the cases. Go to command prompt, run the program, and we are getting the same value over here. In this case we are doing some mistake. This is sum of x and y, I suppose. So sum of xy is there, so we were making a mistake. Anyway, now if we correct this, go back to command prompt, we run it again, we get the values as printed over here. So this was all about the method using Numpy for linear regression. Same thing we can do using the stat model. So we can go to a new file, save as, you can have lin underscore regression 2.py. Now we can import pandas as pd, we can import Statsmodels, but these things have to be in your computer as sm. Now we can call data frame equals pd.read csv, within bracket you can give the file name .csv. Now we have the data values. Then you can change df dot columns equals, you can have I comma x comma y. That will change our columns. If you want to change, you can create a model which is model equals sm.ols. This is linear model for which you have y comma x is the command dot fit. Now model parameters we can see here, but what is y, what is x, it's not known to it. So we can write df y and we can write df x. So if we save it and we see whether it is running or not, we can go to regression 2. Let's see how it goes. Program is running perfectly, but we have to see what it is. So we can print model.parameters. That is a syntax for finding out the values of A and B. So if you run it, the values of A and B are, it is only 2.54. So in this case, the problem is that it is making a model y equal to c into x, but we require a model a plus bx. So in that model, we have to add a constant. So the same may work as x equals sm naught add constant and within this df x. So a constant is added up. When constant is added up, then only we will apply the model. So first we will add the constant, and after that if we see x, print x, and we run it. So we see another column of 1 over here as a constant. So it will be y equal to a plus bx. So that way we can run the model, and instead of this, now we have to put x over here. So x is added constant value. So after running this, we need not to print this, and we go there, clear screen, go there, sorry. If we run this, we get the constants as 64 and 0.6. So if you compare this with the result of the previous program over here, we go there, we can print this, and if we go and print the first one, we will get the same thing. So the constants are same over here, what you see in this case. So these were two models, one using Numpy and another using the stats model. So it is, in the last I could say that it is very simple and very short to do the programming in Python.